Right, so this video I'm calling FizzBuzz, and basically is because it's a game about fizzing and buzzing. So let's just hit clear here. Although I probably won't be using the terminal, I'm going to be using the interactive Python. But you can see the code here, but what I'm actually going to do is I'll shrink this at first and move my Google Bard, because I might be able to and let me just expand it so control is it. Yeah, it is. It makes it bigger. I'm just going to ask questions here, which is what is the FizzBuzz game in coding? I don't know if it's called a game or puzzle, I'll call it. In coding, I just stuck it into Bard. I could have stuck it into Google, and I'm sure I probably got a better set of results out of here. But I'm just doing it like this so we can see. Let's just see if we get anything back. Oh yeah, here you go. So I'm not going to copy this into the code, or maybe I will and I can delete it afterwards. But the FizzBuzz, that'll zoom in even more just in case it's not visible. Control and zoom in one more level. So the FizzBuzz puzzle is a simple programming problem that is often used as a coding interview question. The puzzle is as follows. Write a program that prints numbers from 1 to 100, but for multiples of 3 print fizz instead of the number, and for multiples of 5 print buzz. But that's not it, because for numbers which are multiples of both 3 and 5, you have to print fizz buzz. And it actually puts out this is the answer, actually, funnily enough. So you want to get something like this: 1, 2, and then 3 would be replaced by fizz, 4, and then 5 is replaced by a buzz, 6 is replaced by a fizz. And I don't know if we do get a fizz buzz here, which is 15, because 15 is a multiple of 3 and a multiple of 5. And they probably, GPT sticks you in an example piece of code. I wonder how close my code is actually to GPT. Or not GPT, Google Bard. Google Bard is number one, stuck it. So what I'll do now is, I wonder if I can get the expansion on both of these. So let me just expand my, so I've got a side-by-side version there. There we go. It's about as good as I'm going to get for side-by-side versions. But the first bit is here in the Google Bard, it's actually created a function called FizzBuzz, and I actually was going to do this because my version is just like a little script, and I think it's cleaner doing this. And by the way, Google Buzz, Bard and GPT, they always do this because it's probably the proper way, which is the if name equals main and then call it that way. So I actually will do that. So if the double underscore name equals main, we call a main function. And we have to therefore have a def, and we're going to have a main, right? So now we are able to call a main function, but we'll have another function, and we're going to call our other function FizzBuzz. So we could have a def of another function, and this time let's put in all of our code. So let's just cut it out of here and paste it over here, and remembering to do the tab because Python's indented, needed white space indentation, and we are going to call our function fizz underscore buzz. I think this is actually nicer, but it didn't matter. But you could do either way. But now this is at least more comparable. A function to calculate fizz and buzz. There we go. Very nice. Now, if we are going to do it that way, I think that we're going to need, well, we don't, because here I stuck in 100. But what I'm going to do now is I'm going to take n as an integer and then pass in the value of n over here, because from our main function we're going to call fizz buzz, and then open brackets, and it's telling us it's expecting to get an integer back. We can put 100 in here. That's kind of like, again, the right way to do it. Over here, I notice that Bard doesn't use the type hinting. We prefer the type hinting. Bard also doesn't have a doc string. I think maybe like a standard, you should kind of like put in a one-line doc string, but some people won't put in any doc strings at all because it's a waste of space potentially, because you kind of like know what the function is. But let's say we do that anyway. Let's do a comparison side by side, because I've done for I in range n, and here it's done for I in range 1 to n plus 1. Interesting, because my range starts from 0. So I go from 0 to n, whereas Bard goes from 1 to n plus 1. So it's so that if you put in 100, Bard goes from 1 to 100, where if I put in 100, I go from 0 to 99. But whatever, that's fine. You know, we'll sort of like leave that there. I wonder. Oh yeah, here it was right from 1 to 100. Now I could change that question, going to like write numbers from 0 to 99 or whatever you wanted, start to stop. So I'll keep that. That's quite nice. Now we see that, and here's the thing about it. If I was building this from the beginning, and I did, the first thing that I actually do is an if statement of if I percentage 3. So if I divided by 3 doesn't have a remainder, has a remainder that equals 0, then it's a fizz. And if I divided by 5 has a remainder that's equal to 0, then it's a 5. And those two things work fine. But then, like, if you were to put this one afterwards, then one of these conditions gets hit first. If you do an if and an else if statement, if you're doing if and else if, you've got to be careful of the order. Now, that was when we were using Python. I don't know when I wrote this, but it's probably like an earlier version of Python. But now we've got the select case statement. So can but if you notice something, all of the rest of the code is the same, but I've kind of like saved. If you're going to do the code like this, like, it is proper convention to do a return here and have sort of like the indentation so that it's clear. But actually, to condense it, because it's relatively simplistic, I feel it's allowable to do that, which is an if, then an else if, then another else if, and then finally print the line 9. That's basically it. Sorry, else print I, which is your number. So they're all of your cases. You've either got something that's divisible by both, that had to be done first, then something's divisible by 3, then something's that's divisible by 5, and then everything else just gets printed, because that's the default thing if none of these ifs and else if conditions get triggered. And this time thing's just to time how long the function takes. We've got a starting time t1 and ending time t2. It's quite common for me to do this, which is the time taken, which is t1 minus t2, and that's basically it. Now we stuck it into a main guard. I might actually just run it just for the sake of just making sure that it's worked, because I've changed the structure of it. So it's just launching Python 3.14, and there we go. We got our fizzes and buzzes, and I'm just going to turn it into a scrollable element so that we can see them all. And I start from 0, and the first one is a FizzBuzz, and that's because 0 divided by 3 gives you 0 remainder, and 0 divided by 5 gives you 0 remainder. So the first one is 0. And notice I'll go down to 99, which is, or 98, and 99 is a fizz because 99 is a multiple of 3, because 9 is a multiple of 3. So 99 is a multiple of 3. 33 times 3 is 99. So that's basically it. We get all of the fizzes and the buzzes, and like for something like 90, for example, which is a multiple of 3 and a multiple of 5, we get FizzBuzz. So that's all working. It's all perfectly fine. And I did think somewhere, where is it? Hopefully, oh, there you go. Time taken 0.0 seconds. And I rounded it to 2 decimal places. Maybe if I round it to 5 decimal places, maybe we'll see some length of time that it's taken. No, it's basically the reason why now is because, and here's the thing, I've got to be careful. I'm now taking I'm moving this up here, because now I'm wrapping this function in the main, and also I move all of this up here, so it doesn't take 0 seconds at all. I just wasn't timing anything because I moved it all up there. So we're now timing our function as well, and also this is the main entry point. Right, there we go. And let's just run this now, and I guess, where is it? Yeah, the time taken is 0.001 of a second, so it's super fast doing it, so that's fine. But let's just try to do this, which is, I think we can now put this, instead of doing ifs and else ifs, it might be clearer to do it in a select case statement. So can we put this into, and the thing about these GPT, these transformer things, is I'm not sure if, at least in Python, I think, so the GPTs all, or the transformers, at least ChatGPT does, it locked itself in 2021, but the version of Python that had the select case statement, which I think was actually only version 3.10 or 3.11, was definitely after that, so it might not have, that's why this would be the common answer. So can we put this into a select case statement instead of a if? Instead of an if pattern, there we go. I don't know, like, if it reads it, how it interprets it. I'm hoping that will give us something back. We can have a second attempt, actually. And it goes, yeah, sure, here is FizzBuzz Python using a select case statement, and it looks like it's done it. It's put when. I've not really, to be fair, like, I always used to use select case in VBA, which is really, really handy, and it just never existed in Python. And the reason it never existed in Python, I believe, is because with every select case statement that you could ever envisage, you could also always do the same with an if and else if. So it's kind of like deemed to be unnecessary. But nevertheless, we've got this here. So what I'll do now, and it's quite nice that we put it into a function, is that we can define another function. So def of function, but this time we'll call it FizzBuzz select or case. There we go, FizzBuzz case. So it's not the same name anymore. And it'll still be a function to calculate fizz and buzz over here using, but this time, using case select case. So I think case select or case selection would be something like that. And I'm now going to nick the code, because I can do that. There we go, and we'll check that it all works, because when we put it in here, if it doesn't work, then, okay, annoying thing as usual, which is that, I imagine. Yes. Oh no, okay, it's not that. Okay, one thing that we're going to need to do is have an n as an integer. So that's going to solve the n thing. But here, I'm just going to go over case. Case is not defined. So it's probably select or something. So I'm just going to, what I'm going to actually do is go here and put case is not defined, right? And it's going to probably fix itself. I'm hoping it does. It's got quite good intelligence on it. Case is not defined. It's probably like select case or select or something like that, or select I. It's not case. I've used, you're right, the case statement is not defined. It was introduced in Python if you're using the older version of Python. Okay, now it's going back to the if else if. I don't even think it's that. So I might Google it, or I might just put no, okay, I'm just going to do something like select case Python. Hopefully it doesn't read the upper chat. I'm just going to take out an example because it'd be easier, and then I'll just change it for that. Here is the example. Yeah, unfortunately, it remembers the chat, so I'd sort of like have to go here and do reset chat, and then hit reset, and then do provide a select case example in Python. There we go. A new fresh chat with no memory, so it's not remembering any of the bad stuff. That's one of the things you have to do if you're talking to a chat GPT. So it's not there, so I'm going to sort of like I think I might have to revert to looking it up, and I will do case select Python. I don't even know how to call it. Is it switch possibly? Geeks for Geeks, free code camp. I can use any of these. Age, if, else, if, da 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 da. That's switch, but if lang equals that. Match term. Yeah, I think it's match. There we go. So I'm going to paste this in. I just copied this out of. The pattern looks like this. Now it's not going to be wholly correct, but this is how it works. So actually, I could do. This is match. Let's have a look. Why is that one going to be incorrect? Right, okay, must include at least one case, and it's going to be something like this case. Right, that's our first case. That's going to be our second case. We're fixing this bit slowly by slowly. It looks like case I percentage tree is not allowed like that, so it might have to be. Even if it was going to be this, I imagine that, but it's not accepting that as well. Let's just change all of these anyway. And then the last one is not an else, it's a case underscore is the final one. So we would look like that. For I in range 1 to n plus 1, and I'm just going to do so it's consistent with what I have, it'll be that anyway. For I in range n, which means it goes from 0 to n minus 1, because that's how lists are in nearly all languages apart from maybe 1 or 2. So case 1 print I. Now we wouldn't have that anyway because that doesn't make sense. Match I. So case, right, this is what we want to do. I wonder if we like I percentage 3, I percentage 5. Case. See, that would all be one statement. But that's going to be a FizzBuzz, and if I have to put in if statements, that would defeat the purpose. So, and again, I'm actually kind of like thinking even here, even if we were doing a logical test, we'd need to be careful because if it got to this case, and that would have been satisfied anyway, if we had something that was a multiple of 3 and a multiple of 5, it would have been triggered here. Then it would have anyway been triggered here. So we'd have never have had a FizzBuzz. So we'd have had to be careful about that. So I'm wondering, because you still, here's the thing, because I'd have to check for each of those statements. So I'm not actually sure that a match case works. This would be something like match case. It doesn't accept, it's not accepting that, and I wonder why, because let's just go here. Irrefutable pattern is allowed only for the last case. Irrefutable. saying the brackets aren't closed. Oh, hold on, let's just do this. Why that one then? Because that's probably for everything. Irrefutable pattern. Okay. I percentage 1000. There we go. Right, let's just try that. It's probably still giving this irrefutable pattern thing. I'm just going to go over it, hover over it. It's just not going to be. I'm just going to Google bar that up just to see what that is. That's picked up by Pylance. Right. Pylance is good. It detects errors before you're going to get the errors. I can see all of this red stuff in the breadcrumbs over here. So all of the red stuff that was there, that I moved it off there, all of the red stuff here is all breaks. All of these things. I can get rid of this stuff here. So they're not breaks anymore. We don't need that because that's our pattern. But all of these things here are kind of like broken. So yes, that is correct. In Python, the irrefutable pattern is only allowed for the last case statement in a match block. This is because the irrefutable matches any value, so it would always be true if it were placed in any other case statement. Case hello. Well, that's accepted. Let's do match case. Now, because it's trying to match I with something, for example, like 10 would work, I think. 10, right? But I don't want that. I want it to be, I want it to match. Well, I do want it to match with this effectively what's in these else if statements. That's exactly why. I'm trying to see if I can get this working. I don't think so. Without nearly duplicating this, because I'd want to say Fizz. So I'd have else if, like, this would already satisfy my criteria. So I'm actually going to say that you can use match case for various things, but I'm not sure that it works there. Or maybe it does if I put this into a loop. No, because then it should still work. As in, it doesn't allow for checking for patterns by the looks of it. Case 10. I just wonder this. It allows that, which is definitive. I wonder if I could put in an N. Doesn't allow for that. It doesn't even let me put it in brackets. So it doesn't, like, it has to be something that's fixed, like a number, like an integer or a number. I think it'd be a true or false. So I'd have to do the logical test, which means that I'd have to do something like an if statement or an else if, and then return back a FizzBuzz, and then check for it in the case, in which case the FizzBuzz in a match case doesn't work. And I'm going to actually call that, because it's not case select, it's case select in other languages, it's a match case. But anyway, this one won't work, so I'm not going to pursue it. There's no point pursuing something that doesn't work. So that, or sorry, we can make it work, but the cost of making it work would actually be longer than doing this. So this is a much easier, clearer pattern. So I think I remove this. We don't do match case in our particular case here. We stick to the original. We stick to the original question, which was, I deleted all of the original question. But the question originally was, every time you get, so let's check out a set of numbers, and every time you get a multiple of 3, you want to put in a fizz, which is this bit here. Every time you get a multiple of 5, you put in a buzz, you put it here. And then every time you get a multiple of 3 and 5, you get a fizz buzz. And if you were to put it here, and this one was the first if statement, you would miss out on any FizzBuzzes. So it's important. Like when you're building it, you would sort of like build this one, then this one, and then finally build this one. But then you'd realise that and you'd move it to the top because you go, ah, it's not working properly. So that's basically the FizzBuzz pattern for Python. And that's it. I'm going to be moving this also to the GitHub repository. So I only brought it up because maybe I'll zoom in on the code just so that everyone can see this, just to make sure. Control plus plus, there we go. Just to make sure that all of the code is visible. So that's what I was talking about, make it one bit bigger. There we go. So we've imported time just to check the times. We've done t1 equals time.time, t2 equals time.time, so we're timing our function. We've got now the time taken, we print it out, t1 minus t2, rounded to 5 decimal places just to see that. We call our function a function to calculate FizzBuzz. That takes n as an integer. It doesn't return anything back. The reason why is because our return is blank here. We could pass all of this into a list and so like append a list, but we've just chosen to print it out. That would be nice, passing it into a list, I guess, and printing the list out. Which, if we were doing, we could do list comprehension, or we could do something like this. We can make a fizzy list, a fizz buzz list, and we could sort of make a blank list, for example. And then instead of doing print FizzBuzz, we would do FizzBuzz. I could even do it. You know, I'll do a list version actually. So we couldn't do a case select, but we can do this if we wanted to, which is FizzBuzz list. Okay, now we'll make this blank an empty list. So we'll call it our FizzBuzz list. There we go. FBL is equal to this blank list. So we've assigned this empty list. Now we can do list comprehension, and I might break it down into that too afterwards. But here, instead of printing FizzBuzz, we are going to do fbl.append, and then quotations, and I'll steal all of the text. It's probably easier to type it, but it cuts X, there we go, and paste it in here. That's kind of like what we want. Delete, there we go. And likewise over on the next one, it's fbl.append. Right, we could put this into a dictionary as well. We're putting into a list. I might make it a dictionary comprehension after that. And we'll take out our fizz and stick it in here. And finally, you know what I'll do is I'll do just an fbl.append. There we go. And we've got the buzz already in there. It's a little bit faster doing that. Now here we would want to just return fbl, and then because we've called it in our main, we can do, instead of doing this one, we can just do fizz buzz list of 100, and we can comment this one out and run it. I think we get our list back because let's just have a look, because we're returning a list, so we want to print our list. So now we can do like result equals and then print result. We get, oops, oh, just R actually, sorry. So that'll run, and now I wonder why we just printed out our. Okay, did we run? We didn't run a FizzBuzz list. Okay, that was our FizzBuzz list. Else print I. Okay, fbl.append again. I. There we go. So now what we have is this long list of things that, again, 0 is a FizzBuzz, then you've got 1, 2, 3 is a fizz, and so forth going on. Now, if we're doing this kind of pattern, we can put this into a list comprehension. But actually, I'm going to say putting this into a list comprehension. List comprehensions are I believe they're faster than just making it a list and then appending a list. And they're more succinct. But when you've got multiple statements, it's not that we can't do it, but the list comprehension actually ends up looking a bit more complicated, and it's not as intuitive. But the list comprehension would look something like this. It'd be something like FBL again is equal to, and then your list, and then it'd be I don't know, I for I in range n, but then Control Z, right there. And then you'd have to have all of these if statements, but you'd need 3 of them: if this, and then if that. And I'm not even sure that you could necessarily, you'd have an if this, then an else if this, and an else if that. So it'd be a bit ugly manufacturing that. So I think this is a nicer pattern. But one thing that we can do is change this to a dictionary. Because if we change it to a dictionary, okay, we're now not appending, so we just don't get this one line. Or maybe I'll do a dicta version as well, right? Because it's easy enough to do. Oops. So that's our list version. Just to show that we can do the same thing, I'm going to take all of that. And our FizzBuzzes, this time is going to be a dict. And you'll see why. Because a dict's going to give you this key value pair stuff. And it's quite nice because I think I can just do there FBL of I is equal to FizzBuzz. So our key will be the I, which is the index number 0, 1, 2, 3, 4, all the way up to 99, and our value will be if it's a FizzBuzz and so forth. And I think that's going to be nicer in a way. So FBL I is equal to Fizz, and finally FBL, well, not finally because we've got one more after that, I equals a buzz. And now finally FBL of I is equal to I. So like 2, 1, 2, 4, not 5, 7, and so forth will all be just that. And it's going to return FBL, but this time it's going to do the dictionary version. So we can go here, we've got our list version over here, we've got our old classical version over here. FizzBuzz, I don't know, let's just have a little think of what it is. This is like a FizzBuzz, calculate FizzBuzz in a list. And here we're returning back, like if I hover over it, you can see actually we're returning back a list. So I'm actually not going to like put an arrow to say we're returning back a list, because we are. The linter has recognized that we're returning back a list because there's only one return, and that is a list of type list. And likewise here it's recognizing that we're returning a dict because we've created the dictionary here and we're returning the dictionary here. So that's all, it's all done for us effectively. What should I call it? I'm thinking FizzBuzz. This is like FizzBuzz classical, like I don't know, like what we'd call it, but it's not returning anything. I could call it FizzBuzz no return. But finally, anyway, we've got that one there. I mean, each time we can time it. If I was going to time it, I'll do what I did in the last video, really, and put that into a wrapper function so that we could decorate it, and then we could have all of our times. What have I just done? I've just changed all of my formatting. Let's just go back and make sure that's all right. We're back. So if I do Alt Shift, I can move the time over there. That's timing the first one. But actually what we're now going to do is we're going to do a, so in theory that was our first method. Our next method was putting it into a list. They're all going to be similar times. So, and then we can print R, and we just like print the time taken. So I might just do the wrapper of one of them. You know, we can wrap all three of them for now because they're not going to take that long, any of them. There we go. So everything, all of the three functions are going to be in there. We're not running one of the functions anyway, which is this one. We're running the second function, which is FizzBuzz, and printing R. But we'll do the next one, which is, I can literally copy nearly all of this because all I have to do is change this one on, so it's a FizzBuzz. Fizz, I like the IntelliSense because it really helps you. FizzBuzz dict. There we go. And we're going to print out a dict this time. And we can see now in our dictionary, we've got like naught, FizzBuzz, 1, 2, 3. And what we could do is, I guess, for both of them, we could do for I in list, print I, and so forth. But here, I think it'd be quite nice in the dictionary for I in dict, or not in R dot items, and R is a dictionary because that's what came back. So a dictionary dot items print I, so something like that basically. And now we can see all of our key values. So we can see a 0, 1, 2, 3, and it's sort of like printing out all of the items. We could have done for key and value in r.items print key, and then I'll do it as an F string, something like key, and so like colon, and then value there, so something like that. That would look quite nice. And then we get like a 1 gives you a FizzBuzz, so 0 gives you a FizzBuzz, 1 gives you a 1, 2 gives you 2, 3, and so forth. So we can do that as well. So we can go quite elaborate, and again here in our list we can do a similar type of thing, because at the moment our list is sort of like a one-liner here, and we might want to expand it, but we can do this. We can do for I comma v, and this is quite nice because it shows a similarity between a list and a dictionary in fizz be r dot, and then enumerate. And enumerate are basically takes out the index, because a list it actually explicitly shows you the index and the value item that you've got in there. So it would actually give us something very similar to this here. Copy that and paste it over there. But we're just using an index instead of a key value pair. We're using the index of the list and the value. So now we've done both. If I run it, I've got to just, when I do that, because there's so many items, I'll do scrollable element, and that's our dictionary version, and this is our list version. They look the same. So prints list method, right? The dict method, by the way, is faster. The list method is like conceptually maybe easier. You start with a list, but dictionaries are hash tables, so they've got advantages for speed. Dict method, and we want probably over here print. Looks like we finished it. There we go, and that one here, just to sort of wrap it nicely and make it all look good. Print statements in, and we run it. we can turn it into a scrollable element. We can now see our, where is it? Scroll right the way to the top. Our list method, 0, FizzBuzz, 1, 1, 2, 2 there. And likewise, and it goes all the way down to 99, we don't get to 100 because we're going from 0 to n. In our functions over here, we just takes n, and we're doing a range of n, and range of n goes from 0 to n minus 1 basically. So we go from 0 to 99, but that's what we get. And then we've got our dict method, and all three, well, all three, but actually both of these methods, this FizzBuzz one here and this FizzBuzz list and this FizzBuzz dict, the sum of both of them, because they're all inside the T1 and T2 range, has taken that many seconds. And if we had our classical method in there as well, which we could have done, I could still put that in there actually. Maybe I will copy that, paste it here. This will be FizzBuzz classical method, and kind of like, let's copy this one here, copy that, and paste this one over here. What we don't get with our classical method, although we could produce it, is we could print, instead of printing just FizzBuzz, we could print I, FizzBuzz, and then it would look the same as the other two. But I'm going to leave that one out. But if I then did run it, we'd get something that's 300 lines long, because we're doing 3 different loops that go there. That's our third one. That's our dict meth, which was our last one. This is our list meth. It looks exactly the same as the last one. And then finally, if I keep scrolling up, that's our classical method. So we've got all 3 methods now. So now I could probably call it FizzBuzz 3 ways. And I'm going to I'll probably upload this code into GitHub again and share the link. I think I might just do that. And that's basically it. So FizzBuzz now done 3 ways. A classical way, using a list by appending a list and returning back a list, and also by doing exactly the same but with a dictionary, so modifying a dictionary. And that's it. So if you like this video, hit the like button. Well, at least if you found it useful or helpful in some way, hit the like button. Definitely follow, that would be very helpful, getting followers. And if you have any comments as well, or improvements or different things that you can think of that one could do, then do that as well. And that's it. FizzBuzz 3 ways.